Welcome back, guys. This is video number 5 for Metrology and Quality Control. So last video we discussed the X bar, R bar chart numericals. 4 examples we discussed. It's pretty simple. X bar, R bar calculation, process capability calculation, population standard deviation calculation. How to calculate 3 sigma X bar or 6 sigma prime we discussed. So these are all the things were important in terms of X bar and R. So that all comes under control charts for variables. Now we'll be discussing about the control chart for attributes. So attribute means attribute type of data. So in that you will be having 4 charts: P chart, NP chart, C chart, and U chart. Okay. So how to classify or how to identify whether to go with the P chart, NP chart, C chart, or U chart, you know very well. So maybe in coming slides also I'll give some brief introduction about that. So what is P charts? P chart calculates, wait, let me use some pointer. Okay, so P chart calculates the percent defective in sample. Percent defective, the percentage it will be proportions or percentage will be calculating. P charts are used when observations can be placed in such categories, 2 categories. What are the things? Yes or no, good or bad, pass or fail, like that, accept or reject, like that. Yes or two alternatives only you will be having. But in terms of variable, you measured it, right? Diameter or width, length, kind of thing. But here decisions are defectives, yes or no, good or bad, pass or fail, like that. That is P chart, but P chart mainly percent defective, percentage of defective. C chart, maybe NP chart also comes under that, depends on number of sample and what kind of variable, what kind of sample you are taking, whether samples are constant or random. Then C chart counts the number of defects. Here percent, here counts. So remember, guys, P chart discussing about the percentage of defective, but C chart, as a P chart is discussing about percentage of defective, C chart counts the number of defects in an item. It will count number. C chart are used only when the number of occurrences per unit, means defects, number of occurrences, number of defects per unit of measure can be counted, such as number of scratches, number of cracks, like that. If we could able to count how many number of cracks available, how many number of scratches available, then we have to go with the C chart. U chart counts the number of defect per sample. So this one, C chart and U chart different is, in C chart counts the number of defects in an item, in particular one item, how many number of scratches available, how many number of cracks available. If you are counting and analyzing, that comes under C chart. But in terms of U chart, this also count number of defect, but per sample. Maybe from some 8 subgroups or 9 subgroups or 10 subgroups, if you take one subgroup, in that you may be having 6 sample, you may be having 10 sample, you may be having 25 sample. Out of 25 sample, how many number of defects available, if you are counting and analyzing, that will goes under U chart. But in terms of C chart, you will be taking one item. In that one item, how many number of cracks, scratches available, if you are calculating and analyzing, then C chart. But P chart discussing about in terms of percentage of defects. So if you remember that, this understanding, it is fine to decide whether which chart we have to consider for control chart of variables. Sorry, control chart for attributes. So formulas similar like your X bar, or you have here also central line value or central limit, upper control limit, lower control limit for P chart. P chart means fraction defective, percentage. NP chart, number of defective. So what is the difference between P chart and NP chart? You know from this, I'll repeat again. C chart and U chart. C chart per item, in particular item, how many number of defects available, like scratches or cracks available. But U chart, in one particular subgroup, total number of samples available. From the total number of sample, how many number of defects, if we could able to count, then it will goes under U chart. For each, there is an equation. P bar, center line is P bar. In terms of NP, center line is the NP bar, and C chart, C bar and U bar. It's not P double bar, NP double bar. In your X bar only, you will be having X double bar as a center line. But here, P bar only. So how to calculate the P bar? Summation of NB divided by summation of N. N and UCL and LCL. These formulas, if you remember, it will be fine. P bar plus 3 times the square root of P bar in multiplied by 1 minus P bar divided by whole divided by N. And here you will be having minus. Similarly, here center line, same summation of NP divided by K, and also in center line also summation of C divided by K, and values or formula, please remember. Then I think it is not new for you. Attribute charts, how to decide P and T, NP or C or U. You know, based on the explanation, you understand that. Same thing it is repeating. Proportion, numbers, count per unit. Unit means from one sample size how many, and how many number of errors or scratches available in one item. C chart, NP chart and P chart. Then it's the same repetition. I don't want to explain again. So remember that. So some point. P chart, fraction of number of non-conformity, number of defects, and number of non-conformity per unit. Difference between defect and defective. Defect, a single non-conforming quality characteristics. Defective means items having one or more defects. Okay, that is defective component, or defect means single non-conforming. Okay, so let's move on to P chart. So P chart is percent defective chart. So in other words, we can say percent defective chart is called P chart. So instead of P chart, they may be asking to you to draw percent defective chart. In the sense, you should assume it's just a P chart. You should understand it's a P chart. So P charts are used to measure the proportion of items or percent of items in a sample that are defective. So defective in the sense, more number of failures or non-conforming things are available. So which are used to measure proportion of items in a sample that are defective. Examples are the proportion of broken cookies. If you consider one pack, broken cookies, how many number of proportion of broken cookies available in the pack, you can say in a batch. Or another example, proportion of cars produced with a misaligned fender. So misaligned fender, you know, fender means in front panel there's a light, headlights will be there. Along with the headlight, you will be having panel, right? The side panel, that is called the fender. So how many number proportion of cars produced with a misaligned fender? So this some company will do lots of assembly in that. They check or they analyze about how many numbers misaligned with with respect to total number of cars being manufactured or produced. Then you have to go with the percentage of defective. So P charts are appropriate when both the number of defective measured and the size of the total sample can be counted. Okay, for example, proportion of cars produced with a misaligned fender, in the sense how many number of total sample you are taking. You can able to count if you are counting that, and also number of defective cars. If you can able to count both, then it is better to go with the P chart. The proportion can then be computed and used as the statistic of measurement. In this chart, we plot the percent of defect either per batch, per day, per machine, etc. like that we can go. So remember, P chart means proportion of items in a sample that are defective. Percent mainly, you should remember. Then equations for central limit, mean, proportion defective, that is P bar. P bar equal to total number defective divided by total number of items sampled. So both needs to be counted. So we can able to count in terms of car, fender, misaligned fender, in the sense you will be taking number of sample cars and you will be checking the how many number of misalignment. So total number of defective also you can able to, and also total number of items sampled also you can able to count. So with this ratio you can able to calculate the P bar. Once you know the P bar for upper control limit and the lower, this is LCL. It's a mistake UCL, no, it's a LCL. So upper control limit and lower control limit equation is there, formula is there, P bar plus 3 times in square root P bar multiplied by 1 minus P bar divided by N. So, and also if you do with minus, then it goes with the lower control limit. Okay, so this will, you can able to calculate upper control limit or lower control limit. So example, during the first shift, 450 inspection are made of book of the month shipments. Okay, and five non-conform, NC means non-conformity units are found. Okay, out of 450 book inspection, out of 450 inspection, five non-conforming units are found. Production during the shift was 15,000. So for total number of product or books made is 15,000 units. What is the fraction? So if you want to identify the fraction, total number of defective divided by total number of items sampled. Okay, total number of defective divided by total number of items sampled. So total number of defectives how many? 5 non-conforming units. So N will be your total number of defective, that is NP, divided by total number of items sampled. 450 inspection. So they taken 450 sample and inspected. So it should be 450, not 15,000. So 450 if you substitute, you can able to calculate the P bar. Okay. So this P bar will be 5 divided by 450, you will be getting. So generally P is usually small. Say it should be less 0.1 or lesser. If P value is greater than zero point 0.1, which indicates that the organization is in seriously under difficult situation. Just for example, it is giving general guidance they are giving. So once they calculate the total number of defective divided by total number of items sampled, if they are getting the value greater than 0.1, then it may be assumed like something is going wrong. So they have to look back their production process and rectify some issues are there if there is a issue. Okay. Some example, they are given a table. Just I given taken a table. So in this table, subgroup number 1, 2, 3, 4, 5 directly, and a number of items inspected in each subgroup. Maybe you can consider day 1, 2, 3, 4, 5 like that, or every hour. So total subgroups are given and number of items inspected 300 each equally, and NP value they have given and P value also given. So NP is number of defects, number of defectives from this number of product inspected. Out of 300, you got 12 defectives. Out of 300, you got 3 defective. Out of 300, you got 9 defective. Out of 300, you got 4. So in day 5, out of 300, you are not getting any defective. So something like that it is given. So once you know total number of product being inspected, sampled, and the number of total number of defectives for each subgroup, it's easy to calculate P bar. P bar is summation of NP divided by summation of N. So summation of NP is what? NP is this one, summation total you have to have 138 substituted, and summation of n total number of samples 300, 300, 300. If you all add together, you will be getting 7,500. With this ratio, you can able to get the P bar 0.018. Once you know the P bar, upper control limit and lower control limit is nothing, because everywhere you are going to substitute only P bar value. P bar value plus P bar value minus, substitute 1 minus P bar here, and n also 300, substitute, you can able to get the upper control limit and lower control limit. Sometime you will be getting negative value from the lower control limit. C minus 0.005 can be considered as a 0. So negative value of lower control limit is possible in a theoretical result. Yes, because we are calculating and we can get theoretical results, but not in practical. Practically we can't able to get. So proportion of NC never negative. If it is coming negative, you can assume it as a 0. Okay, so that is what they are telling for this problem. So in this problem, what are the things you have to take? As per the formula, total number of defective divided by total number of items sampled. If you are very clear in how to find the total number of defective and total number of items sampled, solving for P chart is nothing. Here they given total number of product inspected and the subgroup size, and each day 300, 300, 300, 300. So out of which you can able to calculate the summation of small n 7,500, and number of defectives for each day is given 12, 3, 9, something like that. If you sum all, you will be able to end up with 138. So finally you can able to calculate P bar and upper control limit, lower control limit. If there any negative, you can convert that one as a 0, because practically it is not possible. But when you draw that data points, you are getting 0.53, 0.053, where 0.053 for this particular sample, maybe sample number 19. This is subgroup size 1 to 25. They have given 1 to 25, but some data is not given here, just values directly given. But 25 number of subgroup, each subgroup with the total number of sample inspected is 300, 300. That's why 25 into 300, you will be getting some number. But 19 sample, the P value, that is P bar value, it is 0. What to say, 0.053. So upper control limit, lower control limit you calculated, but this value 0.053 out of your upper control limit, out of your upper control limit. So in X bar odd bar chart also we discussed about, if any point is going above your upper control limit in the sense, or below your lower control limit in the sense, they out of range in the sense, what you have to do, you have to eliminate that particular data points from the calculation. Then again you have to calculate the X bar value, R bar value and all. Similarly, in terms of P chart also, if some data points value, P bar value is going above that upper control limit in the sense, for this particular subgroup data, maybe which subgroup data, maybe 19 subgroup data, you can eliminate. So once you are eliminating in the sense what? Instead of 7,500, 300 is gone. So 7,200 only you have to give. Then instead of 138, what you have to give? You have to minus the 16 from 138, what is available. Then with that you can able to calculate the B bar. Accordingly, UCL, LCL will be there. So same thing, the formula wise it is given. The particular data points, excuse me, removed from the data point. Say 138 minus 16, 7,500 minus 300, you get the new P bar value. And similarly, if you found the new P bar value, then you can able to calculate the UCL and the LCL. So once you got all this value, we can able to plot it with the P bar chart if we have all 25 data. That's it. Okay. Then example 2 for P chart. A company that makes light bulbs want to monitor the fraction of defective bulbs, the company decides to select a random sample of 100 bulbs in each day over a 5-day period. So in each day, they want to take 100 samples. So each day, same number of samples, but 5 days they are taking. Each of the 100 bulbs are tested to determine if they light up. If your bulb does not light up, the bulb is defective. Okay, if the bulbs are not lighting up, they are considering that bulbs are defective. The company wants to estimate the percentage of defective bulbs and determine if the percentage of defective bulb is increasing over time, whether it is increasing over time or not, they want to. So a P chart is appropriate tool for providing the company with this information. Why? They are asking percentage of defective bulbs. So percentage of defective in the sense you have to go with the P chart. So sample size n equal to 100, number of samples, that is subgroup, is k, small k equal to 5, x equal to number of defective bulbs in a sample. So each sample out of 100, how many number of defectives there can be represented in terms of x. So we have to calculate percentage of defectives, that is fraction of defective. Then P bar, estimate the process fraction defective. Capital P, process fraction defective, we don't know. P bar is the estimate of P. So how they are calculating? So these are all the data they given. So 5 day, each day 100 sample and number of defective for each day. This out of 100, 20 defective. Out of 100, 5 defective. Out of 100, 30 defective. Out of 100, 35 defective. Out of 100, 24. So once you have all this data, you can able to get the P bar value. Similar like X bar and all, you can get the P bar also using this calculation. So N you have, X you have. So P is X divided by N. X is 20 divided by out of 100. So then defective proportions or fraction or percentage we can 0.20 like that. Then P bar is summation of all divided by N. So 0.223 you get. Okay, 0.23. So 20 divided by 100, 5 divided by 100, 30 divided by 100, 35 divided by 100, 24 divided by 100, all you have. Then sum you have, then divided by all 5, you will be getting what to say 0.23 value is the P bar value. Okay. So what to say here, this one you will be getting 1.14 divided by 5, you will be getting 0.228 something like this. So they converted into 0.23. So P bar also we can able to get. So once we know the P bar, P bar is the same 0.23. How we got summation of P divided by K. K is number of sample and P bar we know. Once we know the P bar, substitute that under the upper control limit and lower control limit formula. You will be getting upper UCL and LCL. This is the value, and we can able to draw the plot. Okay. So from the plot we have to discuss further. Okay, we have to discuss further more. So how the data points are moving, maybe it's going, upper control limit is pink color, lower control limit is dark blue, and central line value is the P bar. P bar value is the central limit. Then data points are given in the cyan color. Okay, so started here going down, again up, increasing and coming back to the normal. So something is going wrong, wrong in the sense below your lower control limit. Like this particular data is going below your lower control limit. So that is what discussed. The estimated fraction of defective bulbs produced is 0.23. That is P bar. Fraction of defective 0.23 P bar. On day 2, P was below the lower control limit. Yes, P is not P bar. P is below the lower control limit. This means that special cause occurred on the day. So since I said from the control charts, either attributes or variable charts, you should understand and infer something from the chart, whether out of control or within control, or it's going one-sided, either positive side, upper control side, or lower control side, or evenly distributed, or both like a 10 points means 5 points above, 5 points below, like that you have to analyze. Then only you're completely understanding the process. So all the data will become available in your chart. You have to analyze, understand better. So once it is, since in day 2 p value is below LCL, due to some special causes, it's not natural causes, special causes, some error occurred in day 2, but again it is shifted back to the normal value in terms of day 4. So we can't able to say with this 5 data it is good or bad, because out of 5 data only one data is going down, went down, until otherwise we are identifying what is the cause for that variation in day 2. We can't say that the process is under control. Otherwise, you have to get more number of samples, subgroups, like instead of 5 subgroups, you have to take 10 subgroup. In that, if you are only one data, then you can eliminate that and you can identify and say whether the process is under control or not. Okay. Then another example for the P chart, they given sample 1 to 20, total number of sample numbers they are taken. It's not a subgroup, it's a subgroup size. Number of non-conforming assembly, each subgroup, how many number of defective items, 7, 4, 1, like that it is given. Okay, so what is the problem discussed about? Yeah, data in the table given the number of non-conforming bearing and seal assemblies in samples of size 100, sample size 100, each sample. Totally they taken subgroup of 20 subgroups. Each 20 subgroup they have sample size is 100. From 100 they have number of defectives, like that. So understand the problem in this sense. So the given size is 100, means sample size is 100, but so total number of samples they taken is 20. That is subgroup is 20. Under each subgroup, 100 sample. Under this each sample, in this particular subgroup, 7 defective, 4 defective, 1 defective, like that. So if you understand this, it is easy. Construct a fraction non-conforming control chart for this data. Fraction non-conforming control chart, you know it is P chart. Okay. If any points plots out of control, assume that assignable causes can be found and determine the revised control limit. So if something goes wrong, that can be from the assignable causes, then you have to eliminate that, and again you have to calculate the revised control limits. That is what they have asked us. So since you know all the data, you have to calculate what each p, then summation of p bar you will be getting, and from the summation of p bar you can able to get the p bar also. So number of defectives you can able to get from here, each 20 samples. Here you will be getting 117 defective items overall summation, and each p1, p2, p3, p4 summation of p's you will be getting like this. So here 100 in the sense each subgroup 100 samples. So number of defective 7, number of defective 7, each subgroup 100 samples, so 7 divided by 100, 4 divided by 4 divided by 100, 1 divided by 100. So P1, P2, P3, P4, P20 value you got. So summation it is available here, and number of defectives, total number of defectives also you calculated from here. Once you have all number of sample 20, number of sample size is 100. This is subgroup size. Number of sample m in this is subgroup size. Sample size is small n 100. Then what is your sorry. So central line equal to p bar equal to in this formula. Summation of I1 to m ai divided by m into n. So remember this. This is another method. P bar equal to summation of I1 to m ai divided by m into n. This ai represent the summation of your number of defectives, which is calculated from the previous table. M into n. M is a subgroup size. N is the sample size. So M is 20, N is 100, AI you calculated from the previous step. So AI, summation of AI is 117. So if you substitute that M into N, 20 into 100, you can able to calculate the P bar. So that is 0.0585. Once you know the P bar, you can able to calculate the upper control limit and lower control limit. In this problem, the lower control limit again comes under negative, which sometimes occur because of the computation is an approximation of the polynomial distribution. Okay, when this kind of occurrences coming, you can make it as a zero. So P bar, once you know the P bar, upper control limit and lower control limit calculation is nothing for you. Okay, but with the plot of CL value, central limit value, upper control limit value, lower control limit, after having 20 data plotted here with the x-axis being sample numbers, means subgroup size 1 to 20, and sample fraction non-conformity, because out of each 100 sample you got number of defectives, right, in your table. So it will be plotted here how many number of defectives are available. If you are plotting over here, see this one P bar fractions like P1, P2, P3, P4, 7 divided by 100, 4 divided by 100, this value P1, P2, this value needs to be plotted with the graph with the P bar and the LCL UCL value. So this table, the data plotted here, but in that one data is out of control, other data is almost inside the one. So what you have to do, you have to eliminate this particular data from calculation. Again, you have to calculate the P bar value, LCL value, UCL value. So this which data it is, since M into N kept 100, but M is instead of 20, you have to eliminate one. So 20 minus 1, 19. Then total number of defectives are 117 in that particular sample. Without like a sample number 12, in the sample number 12 you have 15 number of defectives, so you are removing that. So totally you will be getting P bar. This one, with this P bar you can able to calculate the upper control limit and lower control limit and plot it again. So simply you are removing some data. You are removing this and plotting. No, you have to recalculate with your which data you removed. According without that data only, you have to recalculate your all the limits. Okay, then plot it, and you can able to say the data is under the and the process are under the control or under control or not. Okay, then NP chart equation. I'm not going to solve any problems. If I have any problems, I'll be sharing that examples also. Just understand or remember the formulas. And also for C chart, you have a how to calculate the C bar, summation of C divided by G, and upper control limit and lower control limit. Okay, so U chart also there is a formula. U bar, you are going to use U bar, C bar or U bar. Here U bar, summation of C divided by summation of N. So once you calculate the U bar, you can able to calculate this upper control limit and lower control limit. So with this, I'm going to stop this video for numericals. So I think with the video number 2, 3, 4, you can able to understand how to solve control chart problems. Either it's a control chart problems for variables or for attributes. Mostly X bar, R bar chart or P chart might come for your exam. So calculation is not much difficult. Okay, so if you are very clear in understanding P chart or R bar or X bar chart, it is sufficient. So I given for 2 to 3 examples. Maybe some other examples are available in the textbook which I shared. You kindly refer. Okay, so I'm stopping this video. Next topic. we'll be discussing about last chapter in this unit 5, sampling, acceptance sampling, because I said like how to decide sample. Okay, you are taking some sample, how to decide. So we'll be discussing about that in the next video. Okay, so I'm stopping up to here. Thank you.